Tonight, I'm excited to introduce Ben Jones, who will let us know how well GPT interprets graphs. Ben is an old friend of our group. I've been the organizer since 2015, but I heard Ben talk to this group before then. I remember going to McKinsey. McKinsey used to host our events to hear Ben speak. In those days, he worked for Tableau. Now he's the founder of Data Literacy and the author of no less than 8 books on data visualization. Ben, it's all yours.
All right. Thank you so much, Naomi. And thank you, Cameron, as well, for helping to organize and set this up. As Naomi mentioned, this is the 3rd time I've been able to present to this meetup group. It's got to be one of the longest standing and just this continuous sessions, even through the pandemic. And so it's great to be back here again, talking about a brand new topic, one we've all been looking at pretty closely in the last year. And so it's a real pleasure. And as I was saying in the chat just now, I'm taking a look at the list of names and seeing some familiar ones on there. So that's always nice. And so thank you to everyone who took some time this evening to join in. I'm going to be going through some little experiments I've been doing to try to understand whether these AI chatbots powered by large language models have the ability to read and interpret charts and graphs. So, you know, by no means is my exploration a scientific experiment. I think it could potentially inform one, maybe at some point where, and I know a lot of academics and researchers are taking a look at the behavior of these AI chatbots and trying to understand their strengths and weaknesses. So, you know, I kind of approach this from the point of view of a practitioner and an enthusiast in data visualization. And also I take the point of view of a teacher and a trainer trying to understand, you know, how can I help people learn how to use these tools in their own workflow? So that's the perspective that I'm coming from today. I will be taking a look this whole time at the Q&A. So if you want to put any questions you have, feel free to put it in there in the Zoom Q&A box, as well as, you know, attendees, if you want to keep an eye on that box and vote up questions that you like, that you think are worth us talking about. And so, like I said, I'll just be looking at that right here on my second screen while I present. So now what I'm going to do is I'm going to share my screen so that you can see the content I prepared for you today. And I think this is really the beginning of the conversation of AI chatbots and their ability to essentially speak the visual language of data, which, as we all know, is so important. And so let's dive right into it. So is a chatbot a chartbot? So I've got my little emojis up there to indicate both sides of that coin. And I think you'll find that, you know, it has some remarkable capabilities, but it's not there yet. You know, that's, I guess, the executive summary is that there are some pretty glaring deficiencies still as it relates to how these LLMs can employ some of their image recognition capabilities to take an image that's a chart and actually make sense of it. So that's my kind of high-level summary or overview, but I want to really get into the nitty-gritty and the details of, you know, what is it actually doing under the hood? Really taking a close look at what the AI model is doing. What tools does it have at its disposal? What tools does it seem to be able to use well? What tools does it try to use but fail? And how does it fail? Okay, so that's sort of my again, you know, it is not a scientific or certainly not a statistically valid exploration at this point. It's simply me interacting with a chatbot to see what I get. And so a bit about me, I guess, as Naomi mentioned, I've been involved with this meetup group for about a decade now. I used to be at Tableau, and then I left in 2018 to start my own business at dataliteracy.com. And I work with other people in the data viz space, some people that are, let's say, practitioners of Tableau or Power BI. Also get the chance to work closely with Ali Torban, who's on my team. She just had a new book come out called ChartSpark, which is all about creativity in data visualization. So I recommend you check out her work. And she's a real pleasure to have on the team. In fact, I'll show you in a moment a book that I've written that is coming out next month that she illustrated and really brought to life a lot of the ideas in that book. So She really practices what she preaches and is about as creative as they come in the data viz world. So that's a bit about me and my background and my career. So, coming into 2023, about a year ago now, is when everything started to change, right? ChatGPT had been available for a few months as of this time last year. Of course, we all know how fast its growth was in the early days. And so what happened back in the fall of last year is ChatGPT also added a few other capabilities to what was up until that point simply a text interface, but with the addition of image recognition and speech recognition. OpenAI announced that ChatGPT can now see, hear, and speak, as you can see here in their blog post announcement. And so that's what triggered my initial interest. Right away, I thought to myself, okay, well, if I can upload an image, what if I uploaded a chart? And if I were to upload a chart, would it be able to read it? What would it be able to figure out based on the image that I gave it? And that was what triggered my initial exploration into this exact topic. So I had an early blog post come out. I'll talk to you about it in a bit. And really, it featured Bing because I think Bing had the image recognition capabilities before ChatGPT, if I'm not mistaken. So my initial exploration was all about Bing, which of course employs a version of GPT-4, which is OpenAI's, as of today, its most advanced LLM that's available. And so since then, of course, ChatGPT as well has been given these capabilities. And so I've been investigating there as well. And yeah, calling attention to Cameron's comments about Ali's podcast, Data Viz Today. It's one of the best ones out there. It's actually how I first became aware of Ali and her work. And it's been, I think it's over 100 episodes now. So it's got some great content in there. As an aside, thanks for calling attention to that, Cameron. Okay, great. So, my interest in this topic has led to a few books. So first of all, Learning to See Data, which came out in good old 2020. What a year that was, right? So at the end of that year, it turns out I had a little more time to write books in 2020 than I initially expected because I was staying at home. So like everyone. So at the end of that year, I put this book out called Learning to See Data. And I have to call attention to the work of Tamara Munster at the University of British Columbia in Vancouver. Tamara is on my board of advisors, and I consider her a friend. And she, of course, along with Eamon McGuire, her illustrator for her book, Visualization, Analysis, and Design, put out some diagrams that I feel do a great job of helping people understand the notion of effectiveness and expressiveness of data visualizations. And so, we were able to use those diagrams, which they very generously have put into the public domain, and try to build on them and take that concept from the original audience, primarily graduate students, to a broader audience, everyday business users, because everyone really, that you come into contact with has to read charts and graphs on a regular basis. And so we wanted to really teach those ideas and those concepts. And so we've been spending time in the last few years doing just that, helping people learn how to read and interpret charts and graphs. So that's why I was so curious to find out if ChatGPT could read and interpret charts and graphs. Really curious. So beginning with my own explorations into ChatGPT, it led to this book in last year, ChatGPT Basics, just trying to help people understand what is a transformer, what is a large language model, what is a neural network, and also some of the warnings and caveats about the usage of ChatGPT. What are some of its limitations? What are some of its biases and pitfalls that it falls into? So that was simply focusing on the text-based component of ChatGPT at that time, because that's all that was available back in March of last year. Now, the book that's coming out next month is called AI Literacy Fundamentals. This is the one that Ali has designed the cover for, as well as designing all the diagrams on the inside to try to help take those concepts and explain them, to everyday folks that may not be expert level in AI. So there's the book. It's available for pre-order. It should be coming out here in the next few weeks here. Looking at the question here about the link to the recording. Oh, okay. Yeah, so we'll definitely, Jimmy, thanks for the question. I know that Cameron does a great job of making those recordings available afterward. And so correct me if I'm wrong, Cameron, but we'll be sending that out afterward. Okay, great. Yeah, thanks. So it'll be in the comments there of the meetup.com page. Okay, so let's get into some nitty-gritty here. So I decided to ask these 8 questions, just to kind of see if ChatGPT could do some of the basics. And so I'm using ChatGPT Plus, which is using GPT-4, but I wanted to just see, can it do these really basic tasks? How well can it do them? Where does it get tripped up? So I first just asked, what kind of a chart is this? And it's seemingly maybe the most simple possible task, just identifying a certain type of a chart. And I made this chart, which we're going to see a lot of. It's just a simple chart of population by region. As you can see, each column there, each bar has a certain height, which is a function of the population of the regions that you see represented across the x-axis on the horizontal axis there at the bottom. So East Asia and Pacific, South Asia, Sub-Saharan Africa, Europe and Central Asia, Latin American and Caribbean, Middle East and North Africa, and then in descending order, North America at the end. These are the regions of the world grouped according to the World Bank and the number of people that lived in those regions in the year 2019. Okay, can it recognize a chart type? Does it even know that much? So let's see what it answered. So I'll give it a smiley face here. So it said the chart in the image is a bar chart. Okay, so it already got it right, but it goes on beyond that. It says specifically a vertical bar chart or a column chart. So it gives me 3 other possible names for this type of a chart. And then it goes on beyond that. It says it shows the population sums by region, but the exact populations are not labeled on the bars. Each bar represents a different region of the world with colors corresponding to the legend on the right side of the chart, the year for the data indicated as 2019 at the top of the right corner. So it's already, I would say, showing a remarkable ability to take a look at not just the type of chart and identify it, but also pull out different elements of the chart, like the legend, even the filter state across the top with the year in there. It's recognizing that there are, colors, different colors involved. So it's doing quite a lot of work for us, even just right out of the gate. And it's a basic chart type. It's probably, most would consider it the most basic chart type, the bar chart. So we haven't really thrown it any curveballs yet. We've just given it a simple task and asked, and we got an answer that I think is satisfactory. In fact, I don't think I see even a single problem with the answer at all. And it even went above and beyond what I asked of it to. So already, coming out with some pretty good results here, some pretty impressive results. The image recognition function of ChatGPT seems to apply to charts. Okay, but what about when we get into some of the more analytical tasks? And by the way, if you want in the Q&A, like I said, feel free to ask anything as we go along, but it's also in play to ask other things or other ideas you would have about how else to query or prompt this chatbot to see what else it knows or doesn't know. So feel free. And maybe some things we'll anticipate, and I'll get to that. Maybe other things we've never tried before or haven't thought of trying. And who knows, maybe we can even go off script and play with that. So again, feel free. So one of the very simple tasks of reading a chart, this would be, I guess, at the very low level of data visualization literacy, but of course, certainly a very functional or very, very critical foundational capability would be to identify the mins and the maxes. Just starting right now with the graphical marks, is there a graphical mark here that the software can recognize, the model can recognize as the most or the least? So I gave it the same chart and I said, what is the maximum and what is the minimum category shown in the chart? And again, I would say, A+. It says the maximum category shown in the chart is East Asia and Pacific, represented by the tallest bar in red. So interesting, right? It knows that it can read the horizontal axis, East Asia and Pacific. It also recognizes it as being the tallest bar. So it uses the word tall, so it understands the orientation is vertical or up. And then it, of course, mentions as well that the bar color is red. So all of these are things that it's pulling out. And again, remarkably to me, it's still mind-blowing to me, really. And then it goes on. The minimum category is North America, indicated by the shortest bar in blue. These assessments are based on the relative, and this is interesting. It's giving a little bit of a window into what it's doing. These assessments, it says, are based on the relative heights of the bars, which visually represent the population sizes for each region. Okay, fair enough. So far, so good. I mean, I would say it's crushing it. Okay, so then I wanted to move on to another question, which is to say, can it estimate, the individual values? Like if I give it this bar chart, all it has really is the y-axis with the y-axis tick labels, okay? Can it figure out what one of the bar heights is? So I know for a fact that the Latin America and Caribbean population is around 646 million that year, 2019. Can it figure it out? Does it know? Is it able to look at it and somehow compare it to the y-axis labels? Is it able to do what? I mean, how would it come up with a guess about the value encoded by that bar height, and how close is that guess? I mean, that was so kind of interesting to me to find out. So let's see how it did, right? So here's what it says. The population value for Latin American and Caribbean bar can be estimated by comparing its height to the labeled axis on the chart. Okay, sounds good, right? And it says the Latin American Caribbean bar is represented in green. So far, so good. It appears to be just over half the height of the South Asia bar in orange, which is labeled as 2,000 million or 2 billion. Now, already let's pause right there. So I find it interesting that it even brought South Asia up at all. Like why? And this is the very first time it saw this chart. I hadn't asked it previously. You're seeing the chat in order. So I hadn't asked it about South Asia before. I didn't say anything about South Asia at all. It just seemed to pull that out of thin air. It wants to compare it to South Asia, but it comes up with a number. It thinks it's labeled 2,000 million or 2 billion. I don't know why. I don't see anything. The only place in the whole chart where I see 2,000 million is over here on the y-axis, but it's not connected in any way visually to South Asia. In fact, there's this big red bar in between them. So I'm not quite sure how it got tied up and thought that South Asia was labeled as 2 billion, because it isn't. But it nevertheless decided to go this kind of circuitous route, to estimate the height of the green bar based on what it thought was the height of the orange bar. And so it comes up with a guess of about 1.2 billion. And so that's off by, a factor of 2. It's about twice what the actual population is. So I would give it the slightly confused face or the slightly frowny face and say, that's a pretty poor guess. So evidently it isn't able to do, at this point anyway, of course, we have to keep in mind, I mean, if you're watching this recording, just please remember this is February 2024. So, who knows where it's going to go from here. But it doesn't seem right now like it can take a look at the top edge and like we would do, kind of visually extrapolate across to compare to the y-axis or to look at the grid lines, which are very faint here, to try to see what that value is. It's not doing a great job of that. It's going around it in this rather, I would say, suboptimal way to compare it to another value that it somehow thinks has a label. Notice it does say, hey, this is an estimate and it's not exact. So it's only coming up with a guess, but it's saying it's a rough estimate and it thinks it would, should probably vary. Yeah, good question there from Cameron. Like, it seems to me like if it's having a tough time with a linear y-axis, I can't imagine what it would do with a logarithmic y-axis or something like that. But that would be a great experiment to try. We could even change this to say to a log scale and see if that changes. Does it, for example, and I think this would be a good purpose of the experiment would be to see if it assumes it's linear or if it's able to figure out based on the tick marks that it's logarithmic or not. Yeah, we'll get there, John. It's a good point. Yeah, maybe we can try a pie chart. We should, and we will. I really didn't get too much farther than these bar charts, although there are a couple pies I'll show you in a minute. All right, so estimating individual values, I'm giving it a D. I mean, okay, it's like in the ballpark technically, in the sense that it didn't give me a crazy answer like 10 or 10 trillion or something. It's off by a little less than a factor of two. So not so great. Not so great. Okay, how about ratios? This is kind of when we go back to like Cleveland and McGill's experiments, I believe in the 80s. A lot of what they were trying to do is to understand the human visual cortex, to understand our abilities to make comparisons between different marks in a chart. Let's say two bars and their relative lengths, or two pie slices and their relative um, central angles or areas. So how well does it do estimating a ratio between? And this starts to get really interesting here. It's going to be really funny to see what it tries to do to guess the ratio. So I said, okay, hey, this is the very next prompt. How many times greater is the bar for Europe and Central Asia than the bar for Middle East and North Africa? And I know from the data, because I have the data, that it's almost exactly 2 to 1. Okay, so we see 921 million for the light blue bar for Europe and Central Asia population, 457 for the, I would say, like a light brown color there for the Middle East and North Africa region, almost exactly 2 to 1. So with that, relative factor difference, can it come close to estimating? I would say, yeah, it said roughly twice. So what does it say? To estimate how many times greater the population of Europe and Central Asia is compared to the Middle East and North Africa, we need to visually compare the heights of their respective bars. Exactly. And that's exactly what Cleveland and McGill tried to see how well, humans could do. And so it says the bar for Europe and Central Asia is shown in light blue, correct? And the bar for Middle East and North Africa in orange. I would quibble with the color there. I feel like South Asia, if there's any bar to call orange, I would call South Asia orange. But again, I feel it's a quibble, so I'm not going to ding it too much for that. Some could perhaps see this as some kind of a burnt orange colors. But again, we're in the weeds here, right? It almost nailed the ratio. So I'm still impressed, even though I don't love the color label. It says, at a glance, it appears that Europe and Central Asia is roughly twice the height of the Middle East and North Africa bar. It gives me those caveats, right? Without exact values or scales, it's difficult to provide precise answer. But based on the relative heights, it could be estimated that the population size of Europe and Central Asia is approximately twice that of the Middle East and North Africa, given the data shown in this bar chart. And it says to give you a more accurate assessment or estimate, I would need to actually measure their heights. Now it says, would you like me to proceed with an estimation based on pixel measurement? But instead, I didn't ask it to. I asked it to switch gears and help me know how it would guess a ratio of about 5 to 1. Now that's the difference between the tallest bar, East Asia and Pacific, and that same Middle East and North Africa burnt orange or light brown color. The actual ratio is about 5.07 to 1. So you could fit about 5. And for our visual task as a human, that's more or less what we try to do, is we sort of imagine how many of these brown bars we could fit inside the red bar. And we visually estimate that to be about a certain number. And it seemed like back here, that is more or less what ChatGPT tried to do. It seemed to be able to tell us that it's roughly twice the height. And it was really, I guess, accurate in that guess that it made. So it seemed to be like I got to this point, and my expectation is that it would be pretty close, maybe say something like 4, 5, or 6 to 1, and then it would try to do the same thing, try to just say, oh, it looks like it's this much larger. But it didn't. It took an interesting turn. So the first thing I need to say is that I give it what is this? Like a scary emoji. So it guessed, as you can see here, about 1.5 times greater. Based on pixel height estimation, the population bar for East Asia and Pacific is approximately 1.5 times greater than the bar for Middle East and North Africa. So no, not quite. I mean, that's off by, what, 3 or 4 times. I mean, it's really nowhere close. But notice it has this little finished analyzing box in here. So what is it doing? It's actually going to try to measure the pixel height. It says, for a more accurate comparison, I can use the pixel height of each bar. Wow. that seems like an interesting potential there, because it sees the pixels. It's a computer. The computer can easily, if programmed correctly, tell you how many pixels is in an object. Seems like it could be really promising. Wow, imagine that if an AI chatbot could get into the pixel level and make those kinds of comparisons. It seems like it could be. So why was it so inaccurate? I was curious to find out. So I took a look at the code. You hit the drop down there, and it came up with this result of 1.5. How did it get there? Well, I imported the image, and there's my little screenshot there. Okay. And then it tries to convert it. Well, it creates an if statement to convert it to RGB if it's PNG, which it was. So I gave it a PNG. It tried to convert it to RGB. Okay. And then look in the comments. It's telling you what it's trying to do. So it's saying process the image and find the bar heights. How does it do that? For simplicity, I'll manually input the approximate Y coordinates of the top and bottom of the bars for both regions. Since I can't visually inspect the bars, these are rough estimates and should be verified for accuracy. Let's assume the bottom of the bars, the x-axis, is at Y equals 700 pixels, and the top of the bars are as follows. East Asian Pacific, top Y equals 100. This is an example and needs to be measured. Middle East and North Africa, 300. This is an example and needs to be measured. And then it does the math, calculate the pixel height of each bar, right? So 700 minus 100 for East Asian Pacific, 700 minus 300 for Middle East and North Africa. So that gives us 600 to 400, or 1.5 to 1. Okay, so we looked in detail at the code it tried to execute to figure out these bar heights based on their pixels. And I think it actually used a good method. It's just that it didn't know how to actually get these values out. I'm guessing, but it came up with very incorrect ones. So here is what it would actually look like. I took the image and I counted the pixels myself, just using a screenshots tool. But if you take the top of that image and you go to the very bottom where the horizontal axis is, it said 700 pixels, but it's actually 810 all the way to the bottom here. And then for the top of the East Asian Pacific bar, it's 85 pixels, and the top of the down from the top, and the top of the Middle East and North Africa bar is about 670 pixels down from the top. So if we were to, that means the East Asian Pacific bar is about 725 pixels. The Middle East and North Africa bar is about 140 pixels. And if it did that same ratio, it would get 5.07 to 1. In other words, its method would have worked. It just didn't come up with very good numbers for these pixel values. It's like it took the image and it wanted to do the right thing, and it had an approach and it had calculations and it knew how to calculate the ratio and such, but it didn't get the right numbers. So I would call that the right method and the wrong calculation, the wrong execution, maybe. Okay, so then I was curious, what about if it's really close, like 1.2 to 1? And that would be the case for sub-Saharan Africa compared to Europe and Central Asia. So sub-Saharan Africa has a population that's, about 20% greater than Europe and Central Asia in 2019. So I asked it the same question: how many times greater is the bar for the sub-Saharan Africa than the bar for Europe and Central Asia? And it guessed about 1.5, again, same pixel height estimation for that one as well, but fairly close. Could be better, but certainly not off by the 4 times that the larger comparison was off by. And I don't know if this is something that we can say is some type of proportionality between the actual ratio and its guess, because we've only done a few. But I will say it's a mixed bag. With this job of estimating ratios, it's a mixed bag. I would not say that ChatGPT is very dependable then to take even a simple bar chart like this and estimate the ratios. I wouldn't depend on it to do that. And that's going to be very limiting, for this tool as a chart reading aid. It's going to be a very limiting trait that it's going to not be reliable in the sense of being able to assess even the basic size of a rectangle. Looking at Cameron's comment here. seems like the bot could do better with a web-based visualization. Yeah, maybe it would be interesting to try this again with an SVG or a JPEG to see if not having to do that conversion step from a PNG to RGB, maybe that would result in much, much better values. That would be a great follow-up. So I'm going to write that one down and give it a try. Okay, so let me just keep a note about that. Actually, I'll pull the chats out a little later. Okay, so again, I just took a look at the code, 1.5 to 1. Great question, Randy. Hey, Randy. Did the code use the exact same sample values? You can see what it used here. This is the Python code for that 1.5 to 1. And it did still use the 700 for the bottom of the y-axis, the x-axis, the horizontal axis, 700 down from the top. And then it gave us a sub-Saharan African top at 250 and a Europe and Central Asia top down 400 pixels from the top. And I think it looks like it just got lucky. You know, it got a little luckier, 250 and 400. I don't think that does a very good job of capturing the pixels from the top to the sub-Saharan African bar and from the top down to the Europe and Central Asia bar. I don't think it's just lucky, I think, in the numbers it pulled out of a hat, seemingly. Okay. Now that's ratios, but what about the delta? What about the difference? Can it, you know, and I think we're already realizing that there's a problem here. So it seems like we're at this point probably skeptical that it's able to figure out something as simple as the difference between these two bars. Okay. What is the difference in population? This is the same two bars we just showed it. We just asked it for. But now instead of the ratio, I'm going to ask for the difference. The actual difference is about 182 million people, right? And GPT guesses 348 million. So it's off by almost a factor of 2 again. And so it tells me a bit about how it's trying to approach it. This is actually really fascinating. I went into detail on this one too. Like, what did it actually do? Again, it used this idea of pixel height because it had the method right. Here's the code. So let's look at it closely. Okay, it has, so again, for some reason, it just pulled, it wanted to create a ratio of population to pixels. And it used Latin America in order to come up with that ratio. So it said, okay, the value per pixel then would be the Latin American population, which it believes it has in its memory as 650 million, and it wants to divide that by what it believes is the height of its bar, 280 pixels. That would give 2.32 million people per pixel, right? And then from there, it takes that ratio and it says, okay, now I'm going to multiply that by the number of pixels of the sub-Saharan African bar, which gives it an estimate of 1.044 billion. And it does the same thing with the same ratio, multiplying it by the bar that it thinks is the height of the Europe and Central Asia bar to get to 696 million. And then it takes the ratio of those two, or I'm sorry, the difference between those two, 1.04 billion minus 696 million, that gives us the 348 million, as you can see here, which was its guess. So it, you know, creates this ratio based on one data value, and then it tries to apply that ratio to the other bars. And what I found, so you can see its answer here based on the estimated pixel heights, right? The reference and the reference value, which it, for some reason, decided to pick Latin American and Caribbean this time. Then the appropriate population for the approximate population for sub-Saharan Africa is 1.044.6 million. There it is. And for Europe and Central Asia is 696.4 million. There it is right there. And that estimated difference between them then would be 348.2 million. So it did everything right except the pixels again, because if we take the actual pixels, which I'm showing you here, 345 for the yellow bar, 290 for the blue bar, and actually basing it off of the Latin American and Caribbean, which it decided to do, let's follow its lead. And we can see that the actual ratio is about 3.23 million people per pixel height of the bars. And we apply that ratio to the actual bar heights for these two regions that was the question prompted, and we get the correct answer. Really, really close. In fact, I mean, it's only off by a few percent, right? And so it used the right method. I find it so interesting. It just wasn't able to pull out the right pixel counts from the PNG. That's, I think, the key takeaway here, as you're getting. It's got something about it that knows what to do, but it's not able right now to do it accurately, to do it well. So, of course, what if we just give it data labels? How will it do if I just slap the labels on the bars? You know, is that going to help it? That was the next experiment I tried to run. If I add the labels, does it figure it out? And so it gives me an error. It was interesting. There were a lot of runtime errors in the Python code it was running. But in spite of the fact that there were some errors, sometimes it would still come up with the correct answer. Like here, as soon as I give it the labels, it says the difference in population is exactly 182 million, which is the correct answer between these two numbers. It was able to pull out. And how did it do that? I want to show you a little bit more about what it did to get those. So it pulled into its Python code here a library called PyTesseract. And that is basically an optical character recognition library, as you can see here. So it goes in there and it actually pulls the text, both words and numbers, off of the image, and it converts it into a string. And it also pulled in RE, which is regular expression operations library. What did it use RE for? Well, as you can see right here in this part of the code, it used RE to pull out the M and the comma, which were in some of the values. M for million, comma for the time where it had, you know, more than 999, right? And it just pulls those out and basically replaces them with blanks. So it just gets a basic number. And then it sorts the values in descending order. And then it knows, this is interesting, it knows that it says, well, assuming the OCR has read the values in the order of the bars from left to right as seen on the chart, then it says, well, I know that Sub-Saharan Africa is the third bar over from the left, and Europe and Central Asia is the fourth bar over from the left. And so it creates this equation, the difference between the two. I'm assuming there's a 0 because the population's value sorted 2. That would be the third, and it's 0, 1, 2. And population value sorted 3 would be the fourth in a series of numbers that went from 0, 1, 2, and 3. And so that is what it calls the difference. So it's using OCR to turn the image into text. It's using this regular expressions library to change the text and get rid of some of the characters, the comma and the M. Then it does a sort, and then it does a subtract based on its awareness of the order in the different bars. And that's how it got it right, you know. So this to me is interesting, that once you label, it can use OCR, optical character recognition, to pull off the values in the label. I don't believe it used PyTesseract with the axes before. This is, I believe, the first time. I can go back and double check, but I'm pretty sure it's the first time we saw it do that. Okay, cool. So of course, it's not going to surprise you then to know that it really nails the ratios with data labels. It gets it perfect, 5.07 times greater. There it is. It even has the equation in there. You can see the numbers it's pulled off of the chart are exactly what you see on the chart in the labels right there. So it's pretty good with labeled charts, right? How about individual labels? Now, this is where I was to the place where I thought to myself, it's got it. It's going to totally do fine. It knows these values, even if I just simply have it read an individual value to me. It seems like a gimme at this point. But that's when I ran into some problems. So we start to see some issues. It's trying to extract the population, right? Which I thought we would have no problem doing. But it's getting into one of these loops, if you've worked at all with ChatGPT, it can get into these states where it starts to have problems with some of the code. And it just really kind of can't get there. It keeps trying. This was like multiple attempts. It even tried to use OCR again on the image as a second attempt in the same response. It's trying again. It's trying again, failing, 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 and then eventually saying, I give up, right? So it says at the end here, well, given the time constraints, I won't be able to provide you with the population value through OCR. So it says, sorry, if you have any other questions or need assistance, like, okay, please let me know. So, hey, it gave it a good 3 or 4 tries. I got to give it that, and even apologized to me for the inconvenience. So, I'm Canadian. I appreciate that. We're being polite here. But in any case, it hit a snag. And what was the reason? What was the cause? I don't know. It looks like there are runtime errors. It looks like it's taking what was before a simple task and failing doing it. So even though it can read labels and do math with those labels using Python, it's not super reliable. Now, of course, I was able to just re-upload it. In the very next exchange, I said, okay, well, here it is again. Use the labeled version of the chart to find the population value for the bar corresponding to Latin American and Caribbean. Let's just try again, redo. Nailed it. It even says error in analyzing, and that's another runtime error. But if you look at the Python code there, it just uses OCR and pulls the value right off. No problem, 646 million. So you may have to try a few times. I don't know. It's interesting. Even though it seems like it's within its wheelhouse with these data labels, yeah, it isn't perfect. It isn't going to be able to do it every single time. So this is the code. As I mentioned, it's successful in pulling it out. It gives me a runtime error in here, but it still gives me the correct answer at the end. Okay, so there it is. Okay, beyond that, and I know we're getting close to the end of time here, and again, please do, if you have thoughts or questions or comments, feel free to put them in the chat. I'm really interested to hear what you all think. But I went beyond just these like simple tasks of reading a chart, and I wanted to go beyond that, like as a chart aid, as a data visualization tool for you, for me, for everyone out there, for the masses who need to get better at reading and interpreting charts. Maybe it can be even more informative. Maybe it can even be a coach or a mentor or a trainer per se. So let's just see if it can kind of get there. If I simply ask it for if I ask it to thinking about going up the Bloom's taxonomy here, right? Instead of just telling me what's there and regurgitating it, maybe it can tell me what it thinks about it. So for example, evaluate the effectiveness, right? And I even prompted it a little further. What would you say are the virtues and vices of this bar chart? And it starts off by calling attention to a few things. It likes that I used a bar chart, easy to see the differences. It even happens to like the color coding. I don't love it. I wouldn't use it typically. It's almost sort of gratuitous, right? In this example, color doesn't do much work for us because they're already separate bars with their own labels. So they don't necessarily need another color in this context, but it seems to like that. It seems to think it helps us differentiate quickly. Maybe it gives some visual variety, and some might perceive it to be aesthetically pleasing, perhaps, or others would find it, again, annoying, but that may be a matter of taste. But it calls it out as a virtue, actually, the colors. I would probably not necessarily 100% agree. It does like the data labels. We shouldn't be too surprised about that. It feels it's clean and uncluttered, and it likes the title and the axis labels. Okay, so far so good. What about its vices? Well, I thought it really puzzling that it calls attention right away to a very common blunder we see with charts, which is that the scale, it says, does not start at 0, which is not true. In this case, the scale does start at 0. So it seems to call attention to a blunder that's not there. But in its description of it, it sort of hesitates. It says, if this chart does not start at 0, then it can exaggerate the apparent differences between the bars. But it leaves an if there. So I'm confused at this point. Does it think the y-axis starts at 0 or not? Because it sounded like it did, and then it seemed to backtrack a little bit, maybe. It doesn't necessarily love the shades themselves. It thinks maybe that might be an issue for color blindness. It thinks it needs additional context or a source for the data. Those are great. I love that it said there's no source. That is amazing to me, because we teach that in our courses, that it's so important, to include that data source. And it calls attention to that, which I think is highly important. Okay, and then so some other things in here too. It doesn't love the use of the M without explaining what it is. What do you think? What do you think this was trained on? Is there really a source? I'm looking at John's question here. Is there really a source where chart images are related to how to interpret the chart? I don't know, John. I think it's been given a lot of images, of course, from the internet, from Common Crawl, and of course that would include many, many different kinds of charts that it has been trained on. I also have a custom GPT version where I uploaded all my books and a bunch of other great, online free resources about chart interpretation and such. So I'm trying to create a version of the GPT that is maybe a little bit more knowledgeable about specific principles of data visualization. So I would love to go back and redo all of this on a custom GPT that has some of the knowledge base, maybe that's a little bit more readily available, perhaps, than it's simply its vast corpus of training data. Recommendations, it said, to improve the chart, the designer could consider starting the y-axis at 0. So, okay, again, it's interesting to me that it thinks we got that wrong. Because when I then asked it, even going higher up the Bloom's taxonomy pyramid, if you will, okay, what insights can you draw from this about the world's population? This gets really interesting. So, the data itself just tells me information about the region and the population. That is it. But if you look at what it starts to bring into the response, when I ask it to interpret the chart and to pull insights from it, it starts to talk about things like population density. It starts to talk about things like income, middle income population centers. Europe and Central Asia and the Middle East and North Africa have moderate population sizes. Now, this chart says nothing about income. So where is it pulling that from? Again, it's pulling, it's of course generating this text based on what it feels to be plausible sounding based on its training data, as well as the reinforcement learning from human feedback that it's been provided over many, many rounds of training by OpenAI, different resources. So it's bringing in things like income. It's bringing in things like surface area. If we take a look at some of its other insights, it's talking about, again, wealth. It's talking about the age of sub-Saharan African population. It is known to be younger on average, it says here. So that's fascinating. It's going and getting other, it's generating, it's spitting out other what seem to be facts about these regions, which may or may not be true. I mean, I would say at this point, proceed with caution in any of these insights that it's drawing, because I just don't know. And to get back to John's question, we don't really know where those insights are coming from. And it certainly is reaching beyond what is included in the chart itself, right? I mean, without a doubt, it's going beyond that. Let's look a little more closely at some of those pitfalls. So I really love the topic of pitfalls. That was the title of my second book, Avoiding Data Pitfalls. There's so many of them out there, right? Of course, chart pitfalls are sometimes the most painfully obvious. And of course, there are so many more when it comes to working with data, which was more or less the topic of that book. But there are some issues here with charts that we can throw ChatGPT charts with known issues, let's say, and see if it can pick it up. So here's another version of the chart, and you can see this is like the one that everybody always talks about, which is probably beaten a little bit like a dead horse. But anyway, to use a terrible analogy, but you can see the y-axis here. Same chart, y-axis starts at 350 million. It means the North American bar is a little sliver. So it's just chopped down here. So I was curious. I tried not to lead it. I tried just to say, hey, what do you think of it? To give it the most generic question possible, maybe, to not even indicate that there was a problem, just to say, what do you think of it? And so it does not call attention to, it does. So it lists some virtues, again, some of the same things here, the colors, the sorted bars, the title and labels. And sure enough, in the vices list, it nails it. Y-axis scale, the Y-axis starts at 350 million, which may distort the perception of differences between regions with smaller populations. Starting the axis at 0 would provide a more accurate presentation. Okay, so sounds okay. I mean, it found it, it got it. Its final recommendation: overall, while the chart effectively distinguishes between regions by population size using color and order, the lack of data labels and the potential misinterpretation due to the y-axis not starting at 0 could be improved for more precise and informative presentation. Great. So it gave some good advice. It found the blunder. Maybe a bit of a layup here we gave it, right? Because it's been looking at this chart a lot, perhaps in its chat history. We even had the conversation about the y-axis and such. There was a question about a pie chart. Okay, so what about this one? This is the other blunder everybody seems to know about, which is that you don't want to have a pie chart with slices that add up to more than 100, like this one. And so did it capture that? You know, you bet it did. It got it right away. Overlapping percentages. The pie chart segments are labeled with percentages that add up to more than 100%. 62 plus 68 plus 48 equals 178. Thanks. Actually, I didn't bother to check to see if that's correct. I think it is. Yeah, it is. So it got the math right there. And it sees that that is probably an issue that we had with it. Oh, by the way, I'm sorry. This text at the top is wrong. I think all I said in this prompt was simply, what do you think about this pie chart? But I wanted to give it a curveball, a true curveball, like a really tricky blunder, one that most people don't see at first, in fact, one that most people don't even notice at all. And here it is, and I'm not making any political statement, believe me. It's just, we can see, as you all well know, I mean, people from all over the spectrum are going to do interesting things with charts, right? I mean, come on, they're all politicians. Now, this one's showing the alleged growth, and it looks like a nice impressive number over here, doesn't it? And it is. I mean, we saw some growth in 2021, thankfully, after a real tough year. Of course, this is talking about percent change, not the actual GDP. It's change in the GDP, okay? And it came right after this huge slump from COVID. But the thing that nobody notices, I mean, does anybody notice it? Put it in the chat if you notice it. I'm just curious. Like, do you see there's something about this chart that is particularly misleading in a very tricky way, in a way that's you have to look closely to see it. Most people don't see it at first. You have to look real closely to see there's something done. Yeah, thanks, Darius, nailed it. The 5.5. You see this? It goes up 0, 1, 2, 3, 4, 5. Oh, 5.5. Where did that come from? It just snuck in there. So the distance between 5 and 6 is twice as big as the distance between any other single unit jump, right? What does that do? Well, it only does one thing in the chart, which is that it essentially extends the perceived length of this last bar, right? So, okay, I'm not accusing anybody of anything. What do I know? I'm just simply saying, oh, that's a kind of a gotcha. And, certainly what it leaves us with is a perceived larger growth than what we actually saw. Never mind that the label is also accentuating, perhaps you could say, that final bar. All right, so did it get it? What do you think of this version of the bar chart? I mean, it lists its strengths, its title, its subject, the color contrasting and the highlighting of the data. It even calls out source credibility and the great labels. It allows you to see negative growth with the negative values there too. So I like its identification of strengths, no problem. But in the weaknesses, all it says about the scale is that the y-axis doesn't start at 0, which of course it doesn't because it has negative values. So the way the y-axis does not include 0 in this instance does in no way exaggerate the perception of growth or decline. So it's giving us what sounds like a right answer, and it's similar to the answer and the distortion you get with other bar charts that have a non-zero y-axis starting point. But in this case, that's not what's happening because it's negative values. So it isn't that it's starting at some arbitrary positive value, which would skew the perception of the bars. It's just that it had negative values. So all the bars are still proportionate with respect to the 0 choice, okay? That doesn't change the bar proportion at all. but it seems to indicate that it does have that effect. So it's wrong in that regard. And it also doesn't notice this 5.5 anywhere in here. I don't see it. It doesn't see it anywhere. Nothing. It says nothing about it at all. And it says overall, the chart is visually striking and effectively communicates the trend. Okay. But it could be improved by addressing the weaknesses mentioned above, hand wavy, hand wavy. So I thought, okay, let's lead the witness. So what if I say, okay, hey, what do you think about that y-axis? Is there anything about it that could be confusing or misleading? It calls attention to the non-zero baseline again. And it kind of gets in the ball, it kind of like gets in the ballpark maybe. Like it talks about the scale proportions, but it talks about the difference between +2 and -2. It even mentions something called a break in the axis and saying there is no break. So I'm like, oh, did it get it? I don't think it did. So when I read this description, break in axis, I don't see it calling out that 5 to 5.5 and 6 that Darius made so immediately clear with, like, 8 characters, right? It doesn't seem, it's beating around the bush, but not quite getting it. So I said, let's lead it even more. Can you take a closer look at the spacing between the increments, specifically at the top of the y-axis? I mean, let me just lead it right over there, And I think it gets it here. I think we got it. It talks about non-uniform spacing. It weirdly calls out 5.0 and 5.7, which I don't see. There's no 5.7 there, but it's starting to figure it out, little by little. It's kind of getting it. And it gets it that it's even exaggerating the perceived length of the final bar. Okay. So, I took it to water and eventually I got it to drink, but it took a while. I don't know. I'm not so sure it's in that sense reliable to, on its own and immediately, or certainly early in the chat, catch, I would call a more tricky blunder like that one. All right. So I'm going to stop there. I know we wanted to have a hard stop here at about quarter after the hour. So there's other things going on that we can do. Of course, there's some great questions and thoughts there in the chat. And there's more like with SVGs or with more pie charts, certainly lots more pie charts. And we've only talked about the consuming side of the data visualization equation. There's also the producing side. And of course, we know we can use its data analyst feature or function, which I've done in a couple places on YouTube to show how you can just put a data set, CSV, let's say, into it and ask it questions and have it create charts for you in Python. So I think there's more to be said, about how these multimodal chatbots, LLMs, image recognition can be used in the data visualization workflow. But at this point, I'm a little bit nervous, about them. They're powerful and it's amazing what they can do. And I'm still blown away by the capabilities, but I'm also seeing these major chinks in the armor and this propensity to fall apart, a lack of reliable processing. I'm seeing some brilliant approaches to solving the problem, but the lack of execution and carrying out of the steps required to actually do the procedure accurately. So those are some of the things I think that would come next. So let me pause there. There's more there you can see in the blog post that I can put into the chat. But yeah, for now, I think we'll pause there. And I'm just curious about your thoughts. Is this what you were expecting to see from ChatGPT? Did you think that it was going to be able to do more or less? Are you surprised by any of the capabilities or the flaws? And, yeah, what would be next steps that you would suggest to really, as a community, as a group of academics and practitioners of the discipline of data visualization, really tease out these tools and find out how they can be used and not used? So I'll put that back to you all to see what you think could be done. Oh, I'll just pick up on Randy's comment there. Custom chart analyst GPT. Yeah. So that's what I've been doing a bit. So there's GPT I have here called, well, there's one called Chart Chooser that allows me to, I'm not loving it, but it's designed to try to figure out, like, to give a recommendation for a chart. There's one in here I've got, I think, for actually the chart inspector, right? So this is one where like, can it actually, what's in there is basically a bunch of books and some articles, some Wikipedia pages around misleading graphs. You can see it's my learning to see data book. So, the idea there is, could this custom GPT do a much better job than simply GPT-4? So yeah, I agree with Randy that that would be what I would want to do next, would be to try some of these, more fine-tuned, or at least to use a, not really fine-tuned, to use the right term, I guess I would say I'm using a version of the AI model that is referencing a knowledge base of embeddings of these tokens that could potentially give it some additional context to provide answers that might be even more helpful, maybe even more reliable. Who knows? That's what I think could be done too. It's a good idea. I'm looking at Alex. Oh, yeah. So you're looking into the GPT store right now, probably, right, Randy, to seeing what's out there. Yeah. So some people are already trying to put some things out there like that, like what I've been playing with here. Yeah. I don't like mine. I don't feel mine are ready for prime time. They're more just things I've been trying to see. Again, this all for me, it's all part of just exploring and trying to, I think that's what we need to be doing right now, is be looking at these tools and saying, like, wait a minute, what can they do? What are they good at? What are they bad at? Like, it's really good probably for us each to be doing that and having these kinds of conversations. So I'm not here to say, I'm not an AI homer saying we need to use this stuff for everything. And oh my gosh, nor am I a hater saying we need to just, put it all to rest. I'm saying, wow, interesting tool. Seems like it's got some capabilities. Not sure if I'm really ready to drop it into my workflow quite yet, at least in some of these ways, but certainly something that I'm taking a close look at and seeing what else is going on out there. Looking at some of these other comments. Thank you, everyone. It's really great to see the comments coming through and the thoughts. So Alex saying, I wonder if there's an internal consistency in the skills. Yeah. If ChatGPT has skills A and B, but not C, will it consistently succeed? Yeah, see, I love that, this idea that maybe there are ways to parse out. We talked about some of the capabilities it seemed to have, like optical character recognition, the ability to pull text off of images. It seems like the ability to use Python to do simple mathematics like subtraction and ratios. Those are some capabilities blocks, let's say. But then there's some blind spots or some places in which it falls down. And so, yeah, maybe there are tasks and there are ways of prompting for tasks that would put it in the way of using the capabilities or tools that it has that are maybe more reliable. And there's ways to avoid wording prompts in such a way that it drops it into one of these big pitfalls that it seems to be having. Yeah, that's kind of getting into that next level of understanding of what's happening under the hood and how to, kind of navigate what feels to me like a minefield, where it's so easy to fall on one of these kind of deficiencies, like even in the flow of what would seem to be going really well, it'll just kind of implode. So yeah, is there a way to thread the needle there, maybe? Darius saying it would be interesting to test if ChatGPT can work with or understand rushed and linked charts. Yeah, that's a great point. What if we were to give it some kind of like use its web browsing capabilities? Can it interact with the dashboard or something? I don't think so, but that would be another great test. Yeah, absolutely. What else coming through here? Cameron was surprised by how much background explanation was provided. Yeah, especially the mix of natural language explanation and Python code samples. Yeah, it's bouncing back and forth between its LLM and generating natural language and generating Python code, which I find exquisite. I mean, it's just remarkable to me, and it seems like the capabilities, there's so much potential there. It doesn't always bounce back and forth. Lots of runtime errors. Every now and then it just gets caught in some, kind of loop and then just completely flops. But wow, sometimes it pulls it off. And it's really amazing, Yeah, thanks, John. I found it interesting too. Have you experimented with significant prompt design? I mentioned there's a chapter in my book about that, but that was last March. I mean, there's been a lot that's been written about prompt engineering, for lack of a better term, or prompt design. I use it a lot, ChatGPT, but yeah, I like to read some of the papers that come out about prompts. There was a really interesting one lately about having it do reasoning tasks with like text interspersed that is not relevant to the question. And sometimes the longer blocks of text cause it to degrade somewhat in its ability to provide kind of reasoning in some of its responses. So I'm a student. I don't consider myself to be an expert in prompting. And there are some people out there that know a lot. I love to follow the work of Ethan Mollick. I think he's at MIT, if I'm not mistaken. And he's always on LinkedIn publishing interesting posts relative to prompts and what we're learning from prompts. So yeah, I have a lot to learn about prompts. Just getting started myself, I feel like it's just interesting paper that suggests the quality of the answer is tied directly to the quality of the question. Yeah, and it's a great point. You're right. I mean, so much of what we get out of the chatbot is a function of what we put in. And of course, what we put in is the prompt as well as any other data like images or spreadsheets and such. I don't think the prompts I gave it in this little exploration here, this informal little set of tests, I don't think that my prompts were expert level. They were designed to be very basic. They were designed, I didn't really design them. I can't say that word really. I just simply put in what I felt was the simplest, least leading kind of prompt I could, because I really was curious if I gave it vague, short prompts. I was wanting to see what it would try to do. It may be that I could redo this entire set of experiments with much different types of prompts, and I could get totally different answers. I'm certainly open to that. I think that that's probably some truth to that. It would be interesting to try it again with different styles of prompts, maybe, let's say. So yeah, so great point there. And thanks, John, for the link to the post about the question quality. I'm going to go ahead and pull that up here, as you can see. So I'll take a look at that one later. Thank you for the reference. Much appreciated there. Yeah, and Cameron's definitely agreeing with Ethan Mollick's newsletter. Yeah, he's a really interesting person. I mean, he posts multiple times a day, it feels like, on LinkedIn. It's where I typically tend to follow him and also get his newsletter. Another interesting person to follow is Gary Marcus. He's an AI expert. He's been in the world of AI for many, many years, and he has some very negative things to say about LLMs. So I tend to follow all, the adopters and the folks that are the detractors, let's say, maybe, and trying to take it all in and see what's out there. All right, so I know we wanted a hard stop right now, right, Cameron? So anything you wanted to wrap up with, or anything you wanted to end on before we wrap up the session?
Well, I think before we end, I think we can see from the chat, people are very excited about this presentation. So just moment if people want to silently clap or, but yeah, Naomi usually does the closing remarks, so I'll hand it over to her. I think it was just a reminder that we have a meetup in person coming up next month.
I want to thank Ben for an outstanding presentation. We all found it to be extremely interesting. Let me put video back on. I want to thank him. I want to thank Cameron again for hosting us. I don't know what the meetup would do without Cameron's help. I want to thank all of you for not asking the first question I usually hear, but I'll answer it anyway. And that is, will this be recorded? The answer is yes, it is being recorded. My procedure is, once Cameron sends me the recording, I edit it just if there's dead time at the beginning or end or that, and then I send it to the speaker and ask permission. It's up to Ben whether it gets posted or not. If Ben gives approval, the link will be in the comments on our Meetup page, in the comments under his talk. Again, I hope to see all of you in March live for Kaiser's talk. That one, the question has been, will it be hybrid? No, it will not. It will be in person only. But just as this one, it will be recorded. And if Kaiser gives permission, the recording will be posted. But on the 14th, to see it, hear it, you must come to Datadog. A few days later, you might be able to hear the recording. Once again, thank you, Ben. Thank you, Cameron, and thank all of you for coming.
Thank you, Naomi. Thanks, everyone. Talk to you soon.
Take care. End the recording.